If we have gas influx inside the well, but we cannot circulate the influx out, maybe because of pump problems, or no string inside the well, then, we must avoid overpressure due to gas migrations by bleeding off a calculated volume of mud. First, we need a safety margin. In this example, by shut in the well completely, we let the casing pressure increases due to gas migration, from 250 psi to 350 psi. And then we need a working margin. Again, keep the well shut in, let the casing pressure increase from 350 psi to 400 psi. So our safety margin is 100 psi, and our working margin is 50 psi. Now, we have safety margin, and also working margin. With casing pressure 400 psi, we start to bleed off. Very slowly. To maintain the casing pressure, constant at 400 psi. The bottom hole decreases to the safety margin. Repeat the process, shut in the well again. Casing pressure increases by 50 psi, to 450 psi. While the bottom hole pressure also increases. Then slowly bleed off again, maintain casing pressure constant 450 psi. Every time well shut in, gas migrating up. Casing pressure increases, bottom hole pressure increases. Then bleed off very slowly. Not to decrease casing pressure, but to maintain casing pressure constant. And bottom hole pressure will decrease again, until reaching safety margin. Then the process is repeated, until gas influx arrives, just below the BOP. Volume to bleed is calculated based on influx position. If the influx is far below the bit, or if there is no drill string inside the hole, then volume to bleed is the hole capacity multiplied by working margin, divided by mud gradient. If the influx is in the annulus, then the volume to bleed is the annulus capacity, multiplied by working margin, divided by mud gradient. Example, working margin is 50 psi, casing capacity is 0.0732 barrels per foot, and 10 ppg mud in hole, or mud gradient is 0.52 psi per foot. Then the volume to bleed, for every 50 psi increase in casing pressure is 0.0732 multiplied by 50, then, divided by 0.52, equal to 7 barrels. With influx in the annulus, working margin is 50 psi, annulus capacity is 0.049 barrels per foot, and mud gradient 0.52 psi per foot. Then the volume to bleed, for every 50 psi increase in casing pressure is 0.049 multiplied by 50, then, divided by 0.52, equal to 4.7 barrels. Remember to bleed off very slowly, to maintain casing pressure constant. If casing pressure decreases, then the bottom hole pressure will decrease too much, and could go below the safety margin. If the mud that had been bleed off is more than the calculated volume, then the bottom hole pressure will also decrease too much, and could go below the safety margin.